Hi, and welcome to this month's Vaadin webinar. This webinar, I have a guest with me who is the product architect at Vaadin, a longtime Vaadiner, Leif Åstrand. Welcome.
Hi.
How are you doing this day?
Oh, thank you. I'm fine. How are you?
Pretty good. I hear you have a pretty controversial topic in mind that you are claiming that front-end developers should come and mess around in my server code.
Yes and no.
Yes and no.
Yes.
Well, I think probably better let you explain yourself. So I will share your screen and let's see what you have to say for yourself.
Yeah, thank you. So yeah, should front-end developers define their endpoint APIs? That's an interesting question, and of course, there's a reason for that question. We did this thing called Fusion, and we did some controversial things there, and people keep asking like, but hey, those front-end developers in the endpoints, that doesn't make sense. So we're basically trying to explain now, and also, I mean, these things are good also outside of the scope of Vaadin, so it's a useful thing to keep in mind. And yeah, I'm as said, working as a product architect. I used to say that I help simplify things, and I'm really proud about how we have managed to simplify this thing. So what you see here is everything that goes into an endpoint. And if you compare this with basically any other endpoint implementation, you see that there's almost no annotations at all here. You don't need to say like, hey, this is a get request or a post request. You don't need to say that this is URL parameter or taken from the post body and so on. But instead, everything is just using conventions, and in that way, basically, as said, simplifying things. And then when we get to the corresponding client-side code to use this, so it's really easy. You just import this generated greet endpoint, and then you can just directly use it as from your Typescript to just await and a method invocation on it, and then Typescript and JavaScript takes care of the rest for you. But when people look at this, they see, but hey, I see coupling between frontend and backend. And yes, they are right. But there's always a but to it. And to get to the bottom of that, we need to look at the background a little bit. So in the beginnings of time, this was the typical architecture of an application. It's just one thing. It runs on your own computer or someone else's computer, but it runs there, it stores files locally, you use it locally, and that's it, basically. Then, of course, if you want to switch data with some other, you exchange floppies or something, and that's not always so good. So therefore, we got this thing that is usually called a fat client. So you have all your application logic in one place running on your own machine, and then you have some data on a server somewhere, and then your application and everyone else's application can talk with this data. And this is already an improvement. So basically, from an architectural point of view, what we have done here is that we have split up things that need to be deployed in different ways or in different places. And that then gives, in this case, the benefit that, yes, now you can share data with other application users. But it turns out that this division was still not really enough. So we got next step to this, which is a traditional three-tier application. So the application part that isn't data is still split up into presentation and logic, because quite often you use different technologies there, you use different approaches and so on. So having those separated is also quite beneficial. And then what quite often happens is that the application grows bigger, you get a bigger team working on it, and at some point it's basically too much overhead to just have one team. And then one quite logical way is to say that now we have one team working on the presentation parts. They care about pixels on the screen and reacting to button clicks and whatnot. And then you have this other part, the logic part, which is owned by a separate team, and they take care of all the messiness with dealing with the database. They take care of all the kind of business logic and so on. So with this kind of separation, you can have two teams that each can focus on their own thing instead of just one big team with communication overhead. But then things go on even more, and teams maybe grow even bigger. And then we have this thing with making kind of slices through the whole application. So you might have one team that just, let's say you're building a web shop application. That's the typical example. You have one team that does just kind of the product listing and everything related to that. They do the presentation for it, they do logic for it, and they do the data for it. And then you have some other team taking care of maybe the checkout experience and so on. So with these cross-cutting teams and future teams, so to say, you can grow much bigger without getting the communication overhead. And this is also something that we see, for instance, with the whole microservices thing. That's very much about giving each team independence so that they can focus on their specific thing without having to worry about everything else. But each of those still have their own kind of more or less clear separation between presentation, logic, and data. I guess, well, all of us, probably you also, Marcus, can relate to this thing that it's so much easier when you can just deal with things within your own team instead of having to I don't know, force someone else to do what you need.
Yeah, I can definitely kind of relate to that. It's sometimes frustrating if you have a good idea or a very quote unquote simple fix that you need to do, but then it depends on somebody else doing something and they don't have time to do that until Monday, and then you're kind of stuck there either contemplating an ugly workaround to save time or kind of doing it the proper way and waiting for people to get back to you. So yeah, definitely relate to that.
And also then on Monday they realize that, oh, we have sprint planning the whole day, and then you're Tuesday, and it just goes on and on if you have bad luck. So so
it's not only kind of a technical architecture problem, but also kind of an organizational architecture problem in many cases, definitely. Kind of intertwined into one.
Yep. But by splitting things up, for instance, in this way, you can at least reduce the impact of those kinds of problems. But what does it really mean when we separate things in this way? One thing, because whenever you separate things or split things up, you're adding complexity of one kind or another. So basically you just have more complexity just for communication between these different parts of the application. You need to design the API between them. When you design and publish that API, you get expectations about stability. So if someone else just implements something from your API and then you need to change something, then you need to, I don't know, API versioning or deprecating things and removing them later on or whatever. And then also, for instance, one thing we often see at Vaadin, where we build kind of a different kind of API, it's still the same kind of separation, is that we would really want to know that how are people using this thing, but we don't have visibility into how other code bases are using things, and that makes it difficult for us to make the best decisions. So all those things are kind of drawbacks that you get from separating through these kinds of architectural layers. But then on the other hand, you of course get lots of benefits. First, it helps you keep to your structure. Everyone knows that database code, SQL code shouldn't go into your button click listener directly. But when you split it up in this way, you don't have a choice, and that really helps. And then also, as we said, you can deploy things separately. So your data goes in one place that is shared with everyone. But then maybe the front-end stuff that's hosted from a web server, but actually runs in everyone's web browser. And then the final benefit from these kinds of separations is, again, about teams and having separate ownership. So you can have one team that is specializing in one part of the application, and they can mostly do their business without stepping on each other's toes. So how does this apply to web applications? I would say for, so to say, modern web application, it typically looks like this. So for the front end or UI part, you have Angular or React or Vue or something. I, by the way, put those in alphabetical order just not to get in flame wars. And then as the rest of the application, you just have whatever as long as it's stateless, basically. So communication between those, then typically using REST or GraphQL or something like that. And this is a really good pattern because this on the UI part, the presentation, you have declarative definitions of what the UI looks like. You have one central concept, which is that UI is a function of your state, which really helps avoid lots of bugs. And then that stateless server, yes, it's really awesome if you suddenly wake up one morning and have 1 million users. So definitely something you want to have. And at Vaadin, we also came to the same conclusions. That yes, lots of people like this, and we felt that yes, we could contribute to this because there are things that we think we could do even better here. And I mean, it's not just about, hey, let's take what Facebook and Google are doing and we'll be better than them, definitely. But no, what we are aiming on is the way Vaadin is really about combining Java and web stuff. So we're not saying you can use whatever endpoint system you want. We say that if you use our endpoint solution, our backend solution with our frontend solution, they go really well together. You need to use Java on the server, yes, but you get all these benefits instead. So for instance, you get this benefit that you have an integrated solution that everything just works together and you have type safety and so on. I remember, Marcus, you have also lately been talking quite much about especially those integrated things.
Yeah, I think there's kind of there's a big benefit in especially when you're starting to talk about more complex problems, when you're building something complex of your own, in choosing something that's kind of integrated and works together, so you don't essentially first design a whole lot of you design your own framework out of all these different libraries. You choose one front-end library and say GraphQL for connecting to a backend, then you implement your backend in something and your database in something, and all the kind of ecosystem of libraries you put together there. And that's just in kind of on top of all the complexity of your own application that you end up maintaining. So what we've seen, at least what I've seen, is that it kind of can help if one part of this equation is easier, if you have something that already kind of integrates very well, so you can focus more on just dealing with your own complexities instead of somebody else's on top of that.
Yeah, I really like the slogan you had. Was it like, you will have a framework regardless, the question is just whether you maintain it or someone else does?
Yeah.
Yeah. So yeah, then going back again to this code example. So yeah, what we have here is the logic part, the endpoint, right? And then we have the presentation part, which is the TypeScript running in the browser. And as concluded, yes, there is coupling between those, because what we wanted to have with this integrated solution was end-to-end type safety. So if you change, say you change this greet endpoint, you change the say hello method to return a number instead of a string, and then you would But you would really want it so that your front-end code also immediately gives compilation errors when that happens. And the way we do this is by generating front-end stubs based on your Java code. So we import here from generated/greet endpoint, and this is generated by Vaadin. And that, yes, it gives all these integration and end-to-end type safety benefits, but at the cost of coupling. But this isn't actually, and now we come to the really core of this thing about front-end developers doing endpoints. This isn't as big of a problem, because spontaneously, the way you would look at it is that presentation, that's what runs in the browser, logic layer, that's what runs on the server, and then the data layer, that's obviously your database. But we're already seeing that there's not exactly those lines meeting, because when you're using JPA, for instance, it's definitely data layer stuff, but you're doing it in Java, in your server-side language, basically. So you have, it's not an exact match between those. And we can have the same also with the front-end stuff. So the trick really is to separate those so that your endpoints, they are part of the presentation layer architecturally. It's owned by the presentation team or the front-end team or whatever you want to call it. But it actually runs on the server. And this gives you all these freedoms. And that's where you come to this whole thing that, yes, it is the front-end developers who should be building the endpoints. The rest of the things going on the server, that's logic. That's kind of processing transactions and enforcing business rules and all those things. But the presentation part, the endpoint, that's still managed by the front-end team. One implication from this, of course, is that your front-end team is not just Typescript developers. You need to have, depending on how you do it, either everyone is proficient with both Java and TypeScript, or at least one or maybe two developers who kind of help out with the tricky parts and so on. And also, to not confuse you, the name of this way of thinking, because this is not our idea, it existed already many years ago, and it's known as backend for frontend. So this is, no, I made this the wrong way. No, backend for frontend. Yes, so this is the backend that this front-end implementation uses, and then you can have multiple of those also. So let's have a look at what this means in practice, aside from the things that, well, the same team can maintain and own everything they need. So if we were building a CRM application, what we have is we're doing a view with showing some summaries about all your contacts, all your customers that you're managing there for a specific salesperson. And we want to show a summary of those. So a pie chart or something from which countries each, or how many contacts you have from each country. So the typical way of doing that would be that way. First, we load all the contacts for one salesperson. And then used on that, we map over that list of contacts. And for each of those, we fetch the company information about that contact. And then with that, we can count that how many contacts do we have based on the country that each company is registered for. And this is what you would do maybe if you just have a, so to say, generic backend API. But this isn't really efficient. First, we need to do multiple round trips. First one to load the contacts, and then one or many to load all the companies. We must wait for the first one to return before we can even have the data to do the second ones. And also, we are loading lots of data that we don't really need. We don't need the names of all the companies. We don't need lots of things. So if we could instead just have one single endpoint call for just load all contacts and count them by country, and all the contacts for this specific salesperson, then that would be much more efficient. Of course, this isn't still perfect. We would really want to do this in the backend, but still we have probably gotten 80% of the benefits with just 20% of the effort, when we can really easily add this kind of endpoint, because it's my team, the front-end team owns that and can do that aggregation on the server instead of having to do it in the client.
This seems a little bit kind of familiar as an idea. It kind of reminds me of kind of GraphQL, where also the front-end developer might define kind of a query of what they need. How do you see that these two concepts kind of relate?
It's definitely the same idea, but GraphQL still it's more limited. So with GraphQL, if you just want to say that, yes, I don't want this field from the contact or from the company object, then that works quite well. But if you need to do something custom, really kind of aggregating things that haven't been anticipated before when designing the GraphQL schema, then you still need to make changes. And then when you make changes to the GraphQL schema, then we again come to like collaborating between front and backend teams and so on. So it's definitely the same idea. It's just going a little bit further.
Okay. Good.
Yep.
Makes sense to me.
Great. So yeah, as I said, the original idea also, this originated kind of from situations where you had multiple different front-end or presentation layer implementations. So for instance, you had a web client, and then you had a separate mobile client. And there the problem was usually that the desktop optimized web version loaded lots of data and all the fields from the database for each object. But then the mobile version had a much more optimized user interface, just showing the most important things. And then to avoid having to separately load all the data also for the mobile client, that's when they originally came up with this backend for frontend concept. So web client has one backend for frontend presentation. The mobile client has a different backend for frontend, but they still share the same logic, the same business logic, and so on. It's just they have slightly different needs for what data they need, and therefore they implement that part of the application separately. One thing I often hear also is that, but hey, we need to integrate with third-party applications, so we're already making a REST API. And for that, I would say that yes, that's just another presentation layer, but that external REST API, it tries to be as common as possible. It tries to have really stable documented API. You don't want to have lots of specifics for what your mobile client needs also as part of the REST API that externals use. And instead, by having these separated, just using the same logic, using the same data, you can also save yourself from a whole bunch of challenges there. So this kind of way of thinking is in no way limited, or it doesn't go away just because you have an external API also. So yeah, that's my theory about why front-end devs should be the ones managing their own endpoints. So to summarize here, what we have is basic architectural thing with separating things that you want to be separate from each other, and then keeping related things together. And how you do that separation impacts everything else in your application. This kind of brings to mind one definition of what architecture is that it's any kind of decision that would be difficult to change later. And that's exactly what this kind of, do you do layers this way? Do you do slices with feature themes and so on? And then the next piece of the puzzle, That's Vaadin. Our thinking was, hey, we should have Fusion, which is for those who have a Java backend and want to use declarative UI function as a function of state and so on with a Java backend. And to really get the best possible integration between those two, we end up with code generation, and that leads to coupling. And then to deal with that, we come to the backend for frontend idea, which originally came from when you had multiple frontends, but just as well, it also applies in this kind of situation where you want to have coupling between server-side and client-side code, even though there's a strong separation between the server-side code that is for the presentation part and the server-side code that is actual business logic. And finally, doing things this way also makes it easier for you to optimize how you fetch things. So you can probably it's easier for you to have a better user experience with less data to load, and data can be loaded faster because you can really easily customize how things are loaded over the network. So that's what I wanted to tell you today. I hope it made at least a little bit of sense.
A little bit, yeah. Not a lot. No, I'm kidding. Good. Well, thanks for that. I'll hide your slides for now, but if you need to show something from your screen, let me know.
Yep.
All right. We have this one weird person asking a bunch of questions. His name is Marcus. Let's see if you have any answers for this strange person. So one of the things, kind of, you're talking about this coupling, and I'm looking at this and thinking, does this coupling need to be kind of runtime as well? Like to me, it seems like if we're kind of generating types and stuff during development time, that makes it super easy. But once we've kind of defined those types and they live in a kind of in the front end application, does that mean that potentially we could kind of have, in a way, the best of both worlds? So we could have a really integrated development experience, but also have the possibility of kind of deploying things separately in some future.
So with deploy here, you mean that, or actually, what do you mean with deploy in this context? Or
well, so
when
when you were talking, for instance, about microservices earlier, you said one of the reasons might be for kind of wanting to have this kind of stateless backend and being able to kind of scale different parts of the application may be easy. So one of the things I was thinking is that could I, for instance, serve basically the front end assets could be more or less streamed from a CDN, delivered kind of living on the edge, if you will, and the backend APIs could be then scaled as any other stateless endpoints you might have out there. I guess I'm just picking your architect brain here, not necessarily saying what we have today in Fusion, but just out of interest.
The challenge you have there is that to keep things simple, you still want that when you deploy changes to the front-end logic, you also want to deploy changes to the back-end logic, because, well, you can't completely avoid it. But if you don't do that, you get lots of mess with API versioning and so on. And that's something you probably want to avoid if you can. So in that way, you probably still want to have it so that those are deployed at the same time, so to say. I think it would make more sense then to deploy those as one piece. Yes, you can deploy them to separate servers, so you have a CDN with the static assets, and then you have a kind of application server, or kind of, in a way, you can think of it as an API gateway. It's not exactly the same, but you can think of the endpoints as an API gateway. And that is then, of course, deployed not just on a CDN. But then how that API gateway talks with the rest of the application. You can have all the microservices behind there if you want. And now I think I answered a different question, but well, maybe not.
But in theory, though, for instance, a Fusion app using only these endpoints would more or less be a stateless backend in the broad sense, at least.
Yeah, but definitely it's not something we're supporting right now, but I don't see any big difficulty in making it so that, yes, you can put the statics asset somewhere else. It's just, it hasn't been our top priority so far. So that's definitely doable, and probably at some point might happen, but not right now.
Good. Let's see if we have any outside questions here from somebody besides this Marcus person who's asking questions. A lot of people saying hello to you.
Hello.
But we don't have anything besides that. So when you're designing these endpoints and kind of collecting data essentially on the backend side of things, it kind of translates in practical terms then that you essentially write a data transfer object, a DTO or something that's specific to that endpoint call or view or whatever. Is that kind of the thought here?
In a way, yes. So I guess this refers to the discussion about sending entities or DTOs over your endpoints.
Yeah.
Yeah, and
well, we have
right now I see we've got a question about that also.
Yeah, so we'll bring in Simon here about the requirements for DTOs. I guess I was kind of trying to get towards that, but this is a good segue there. So thanks, Simon. So what are the requirements for DTO? So say you define this kind of backend for front, and what kind of stuff can you send over in that DTO, or what are the limitations?
Yeah, so the way we have implemented it right now, and well, it probably won't change because that's quite big breaking change, is that we just, whatever you return from your endpoint method in Java or whatever you take in as parameter, we just pull it through Jackson and hope for the best. So in that way, you can do almost anything. There's one limitation, which is that we also need to be able to generate a corresponding TypeScript type for things to make sense also on the TypeScript end. So if you have lots of annotations in your Java classes to customize the JSON representation, then you probably might get some problems. But in general, kind of anything that looks like a Java bean and behaves according to what Jackson expects will work.
Good. Yeah, and a follow-up question that I was also about to ask is, like, what if we have kind of more complex object graphs with cycles and things that tend to become a problem in even defining REST APIs or whatever, that kind of you take an object and then all of a sudden you get all its roots and potentially send over a whole lot of stuff that you weren't intending to do.
Yeah, so you can just put an @JSON ignore somewhere and then it just works. On the other hand, or not on the other hand, but in addition, we're also, or I still have to convince the rest of the team that this is an excellent idea. But I've been playing with some ideas about looking at your, again, we get into this discussion about entities or DTOs, but if you have entities, we need to make some things to make it safe for you to send those over the network. But if you do have them, then we have lots of valuable metadata there. We can look at, say, your, with JPA, what's it called? Entity graph settings. You can have those as annotations on your entity class. And so we can look at, or we could, in theory, for instance, look at your entity graph settings, and based on that, determine which are the things that should actually also go into the TypeScript type and which shouldn't. And that's something that we are currently investigating, but no idea if it actually is something that will happen because, well, there's also some scary parts about passing entities straight from the database over the wire. So we'll have to consider that, but it's possible, at least in theory.
Good. Then we had a question. I think we partially answered this, but I think the one interesting part here is that do these DTOs generate the REST endpoints? So what's happening? Kind of mentioned a little bit about how the types get generated, but what's actually going over the wire? What's happening there?
Yeah. So actually, I will answer the question itself. So we don't have any tool for creating DTOs based on the entities. We have been looking at, for instance, I mean, there's a bunch of tools for this, like Object Mapper, and I don't remember the name of the other that is quite popular. So those can be quite good to help you create DTO instances out of your entities. So that's one thing that we are also looking into. Kind of, probably you don't even need any support for it, but just say that, hey, there are these awesome third-party tools that you can use.
Good.
And then actually the follow-up question, they're like getting the endpoints from the DTOs. So that happens automatically immediately when you have, actually we could just show that code example. It was on that slide. So when we have this kind of structure, immediately when you have an at endpoint annotated Java class that Spring can find, then based on the public methods in that class and all the return types and parameter types of all those methods, we generate Typescript for all of those, and we automatically handle all the wire format for that. So you can just then also from JavaScript, from Typescript, if I would change now this string name to some DTO or something, then you can just pass the corresponding thing as a TypeScript, JavaScript object also from the client side, and it would just work. And thanks to Typescript, it even so that if you forget to add some property to that object, then you will get an error in Typescript also saying that, hey, you forgot to do this thing, unless you marked it as optional.
Yeah. Good. All right, let's take one last viewer question here. So Simon on a roll, asking kind of a follow-up to our previous discussion. If we are using open session in view pattern, similar to how Spring MVC does in Spring Boot?
We don't do any pattern at all. So right now, this is again related to the whole thing, like entities, DTOs, how to manage those, that we are still kind of figuring out. So right now we are not doing anything there. It's up to you how you manage your entity manager, or if you just use a Spring Data repository or whatever. So everything just goes through the regular, basically Spring dispatching logic and so on. So you can integrate whatever you want there. You are muted.
I am indeed. So I was just about to say, let's continue the chatting, at least with Simon, but hopefully with more of you people on our Discord channel. We have a new Discord on vaad.in/chat where we can continue chatting with Leif and other Vaadin team members pretty much anytime. And one kind of last question I wanted to ask you, just a little bit about kind of upcoming things in Fusion. What are your kind of top upcoming features that you are really excited about getting done, say, this year?
Well, the first thing I'm excited about is the thing that we're about to release already in beta now, offline support. So it's mostly just really the basics, how you can bootstrap an application while offline, how you can, as long as views are implemented just on the client side, you can navigate between those. As long as the user has opened the application once while they were offline, then you can continue using that online also. And also some helpers to manage your data there, but there's also much more to work there. So that's maybe the thing I'm most excited about right now, at least. And then we have
coming out in the next major.
Yeah.
So 19.
Vaadin 19, which is, I guess, beginning of next month.
Excellent.
Yeah. For me, it's kind of once we pass the beta threshold, then it's mostly out of my mind already, because I'm already thinking 3 releases ahead.
Yeah. So anything cool in those upcoming 3 releases then that we should keep our eyes open for? Or are they secrets?
Right now, the main focus is just to stabilize things, because we want to get a long-term release version out. So that's what we're focusing on right now. And we might be able to squeeze in some small improvements still, but the base assumption is that we just take what we have and make sure that all the documentation is really awesome, lots of edge cases that we probably haven't found yet, and so on. So that's what we have in store next.
Yeah. So hopefully just finding more people to get kind of actually use Fusion, try it out, and give us good feedback on what works, what doesn't work, what needs to get fixed, and that way we can build a really awesome framework for you.
Yes, let us know about those edge cases, because we might not have noticed them yet.
All right. Well, that's it for this webinar. Thanks everyone for tuning in, and we'll be back next month at the latest. So thanks for watching, and I'll see you in the next one. Bye. And thanks, Leif.
Bye.